Pluto is this tiny, far-off object that used to be called a planet. But recently, some well-known scientists like Neil deGrasse Tyson and Michio Kaku have brought it back into the spotlight. They think Pluto might crash into Neptune. And they're not just guessing, they're genuinely concerned that this little world could be on course for a major collision. How could that even happen? Is this some weird cosmic illusion, or is something serious really coming our way? Pluto's path gets super close to Neptune's, and scientists warn that even a small shift could lead to disaster. Pluto, which was demoted to a dwarf planet, is still fascinating. Some experts point out that its orbit runs too close to Neptune's. Tyson and Kaku are both sounding the alarm, warning that this cosmic dance might not always remain stable. Pluto's orbit is unusual. It takes 248 Earth years to make a single trip around the Sun. Since its discovery in 1930, it hasn't even completed one full orbit. Unlike most planets, Pluto follows a stretched-out ellipse rather than a neat circle, and its path is tilted about 17 degrees compared to the main plane of the solar system. This makes it stand out and creates complications. One of the strangest facts is that Pluto actually crosses Neptune's orbit. For about 20 years during each orbit, Pluto is closer to the Sun than Neptune. So, why haven't they collided? The answer lies in gravity. The gravitational tug from other planets, especially Neptune, Jupiter, and Saturn, helps keep Pluto's orbit stable. Think of it like this: Pluto, Neptune, and the Sun are engaged in a cosmic tug-of-war, pulling on one another with invisible strings. Predicting their future positions depends on how strongly they pull and where they started. Scientists describe this stability with terms like asynchronous oscillation, orbital drift, and the VZK wobble. Asynchronous oscillation means that when Pluto is near Neptune's orbit, it's offset just enough that the two never meet. Orbital drift describes Pluto's up and down movement above and below Neptune's path. The VZK wobble, named after researchers, explains how Pluto, Neptune, and the Sun interact gravitationally, giving Pluto's orbit its peculiar yet surprisingly stable behavior. Despite appearances, Pluto's orbit has remained steady for billions of years. In fact, Neptune and Pluto have a special relationship. For every 3 orbits of Neptune, Pluto completes 2. This resonance keeps them out of each other's way. Jupiter's immense gravity also helps lock Pluto in place, while Saturn adds its own stabilizing influence. Back in the 1980s, computer models showed that while Pluto's orbit is mostly stable, tiny changes in its starting position could lead to very different outcomes millions of years later. This sensitive dependence reminds us how unpredictable orbital mechanics can be. Neil deGrasse Tyson, famous for helping reclassify Pluto as a dwarf planet, has often said the change wasn't an insult, but simply a correction based on new knowledge. Still, he warns that Pluto's delicate orbital dance shouldn't be taken for granted. Even tiny shifts over immense stretches of time could destabilize it. Michio Kaku shares similar concerns. While he celebrates the wonders of the cosmos, he also stresses how unstable planetary orbits can be. Both scientists argue for continued observation and study, since the solar system's future depends on these gravitational relationships. In the end, Pluto's situation reminds us that the universe is always changing. Every discovery raises more questions. Even the slim possibility of a Pluto-Neptune collision underscores how dynamic and unpredictable the cosmos can be. For now, gravity keeps the two apart, but the story of Pluto reminds us to keep watching the skies and wondering about the mysteries still hidden among the stars. If Pluto and Neptune did collide, even though the odds are tiny, it would unleash an event unlike anything humanity has ever witnessed. Pluto is much smaller than Neptune, but the force of impact would still be catastrophic. The crash would release unimaginable amounts of energy, sending shock waves of debris throughout the solar system. Fragments could scatter into the Kuiper belt, striking other icy bodies and creating a chain reaction of impacts. Some of that material might even be redirected toward the inner solar system, raising the possibility of asteroids or comets being pushed onto Earth-crossing paths. While this scenario is highly unlikely in our lifetimes, it shows how delicate and interconnected planetary orbits really are. But here's the surprising part. Pluto and Neptune's gravitational dance is so finely tuned that instead of colliding, they actually protect each other. Their 3:2 orbital resonance acts like a cosmic safety lock. Every time Pluto crosses Neptune's path, Neptune is always far enough away to avoid disaster. It's almost like the two worlds are playing an eternal game of tag without ever touching. Still, computer simulations remind us that orbits are not carved in stone. Over billions of years, even small nudges, perhaps from passing stars, rogue planets, or shifts in the Kuiper belt, could eventually disrupt this balance. That's why scientists like Tyson and Kaku remain cautious. They see Pluto not just as a lonely dwarf planet, but as a reminder of how fragile cosmic order can be. For Earth, the direct danger of a Pluto-Neptune collision is almost zero. The timescales are simply too vast, stretching far beyond human history or even the lifespan of our species. But the idea of such a crash forces us to think about planetary dynamics, cosmic chaos, and how lucky we are to live in a relatively stable solar system. Pluto's story is more than just a debate over whether it's a planet. It's a symbol of cosmic mystery, an icy wanderer on a tilted, eccentric path that continues to challenge our understanding of gravity and motion. Its strange relationship with Neptune is a cosmic balancing act that has lasted for billions of years. Imagine, for a moment, what it would be like if Pluto and Neptune truly were on a collision course. From Earth, we wouldn't see it happen overnight. It would take centuries of gradual orbital shifts. But astronomers would notice first, watching as Pluto's careful resonance with Neptune started to drift. Computer models would predict the eventual crash, sending shock waves of anticipation through the scientific community. As the two worlds drew closer, Pluto's icy surface would begin to feel the immense tidal forces of Neptune's gravity. Cracks and fractures would rip across its crust, releasing geysers of frozen nitrogen and methane into space. To telescopes, Pluto would appear to tremble and break apart before the final impact. When the moment came, the collision itself would be an extraordinary cosmic event. Neptune, a gas giant more than 17 times the mass of Earth, would hardly be moved, but Pluto would be obliterated. Its rocky core might plunge deep into Neptune's swirling atmosphere, heating up and creating massive shock waves that could ripple across the planet's icy blue clouds. The debris would form glowing arcs around Neptune, temporarily creating a new system of rings. From Earth, even at billions of kilometers away, we might see a sudden brightening in Neptune's region of the sky, a flash as kinetic energy was converted into heat and light. The collision could outshine entire galaxies for a brief moment when observed through powerful telescopes. In the aftermath, astronomers would study the changes closely. Neptune's orbit might shift slightly, though not enough to endanger the solar system. More likely, the greatest effect would be the creation of a new debris field, scattering icy fragments across the outer solar system. Some might eventually fall inward, turning into new comets streaking across our skies thousands of years later. But this is the realm of what if. The reality is that Pluto and Neptune's orbital resonance make such a catastrophe nearly impossible in any foreseeable future. Still, thinking about it helps us appreciate the delicate balances that keep our cosmic neighborhood stable. In truth, the idea of a Pluto-Neptune collision is less about predicting doom and more about reminding us how dynamic and unpredictable the universe can be. Gravity is both the architect and the trickster of the cosmos, creating order but always leaving room for chaos. Pluto's strange orbit is like a riddle written into the solar system itself, challenging us to look deeper, calculate more carefully, and never assume that what we see today will stay the same forever.